Directions here say find the zeros of a polynomial function. Well, sometimes it just so happens that we can find the zeros when we set the function equal to 0 first. But sometimes we can find the zeros to a function, to a polynomial function, just by factoring it. It is by far the easiest way to do it, which is why it's one reason we have to become proficient in factoring, is that this is the easiest manner in which to find these zeros. If we can do this, it's going to just make the problem solving that much easier to do. So when I look at this function, I notice that there's a common factor of x. So I take that out. I look here, and is it possible to multiply to -6 and add to -1? And it is. So x minus 3 and x plus 2. And if I solve each of these, we get x equals 0, x equals 3, and x equals -2. These are our zeros. And let's remember what zeros are. Zeros, these are the places where, the graph of f of x crosses the x-axis. Okay, so let's never forget what we're actually finding when we find these zeros, is we're finding our x-intercepts. Zeros, x-intercepts, they're almost one and the same usually. We're talking about real zeros anyway, they are one and the same. So we found where this graph crosses the x-axis, and we did that by factoring in this particular example. This next example, we're asked to find the zeros of the polynomial function. So again, that's like setting this equal to 0. But you notice here, this one does not factor. I know what you might be thinking. You're looking at this and you're saying, but wait a minute, -7 and -1 multiply to 7 and they add to -8, so sure enough this should factor, right? But it doesn't, because I don't have x squared and x, we have x cubed, x squared, and this term doesn't have an x. So there is no common factor of x all the way through to get us started like in the last example. And just because I can't factor it doesn't mean this doesn't cross the x-axis. Doesn't mean it doesn't have zeros. So we have to find the zeros. And again, a lot of what we're going to do in the next few lessons will go over how do we find those zeros. But in this particular section, if we can't factor, we're going to rely on our graphing calculator instead to help us find the zeros. So I'm going to begin in the y equals screen. Let's see if I can find a place we can see this. The y equals screen. I'm going to type in my function. X raised to the third minus 8x squared plus 7. I'm going to graph it. We know this graph can cross the x-axis 3 times. And there it is, 1, 2, and 3. So it does cross 3 times. And we've done this before, so this is not brand new to us. So we calculate the 0. I'm going to put the cursor on the left side. On the right side, so we're just starting right there, and that's my first 0, and I just use a decimal point. Okay, so let's write that down. X equals -0., we'll just go 8, 9. Oops, sorry, there it is. And in that manner, we're going to go through and find all the rest of the zeros. Now, I'm not going to do that on the video because, like I said, we've done this a few times in the year already, a few times in this course, as far as walking through the steps on how to do that, and we've done it in class a lot too. So, but that would be a way to solve, again, this particular function when we can't factor it. Okay, it's not ideal because we're getting numbers, we're getting irrational decimals, you know, so we're not getting exact numbers, but it's the best we can do, I suppose, in this particular instance at this point in time. It's the best that we can do. But again, just to reiterate, this is not done. You'd find the other 2 places on your calculator. Next, we're going to look at what we call the multiplicity of a 0. This says that if f is a polynomial function and x minus c raised to the m power is a factor of f, then c is the 0 with multiplicity of m. Okay, now what are the implications there? If we have even multiplicity versus odd multiplicity, okay, a 0 with even multiplicity, so if this binomial here is raised to the second power or to the fourth power, an even number, then the graph will bounce off the x-axis at that 0. Okay. Versus if this is odd multiplicity, if this is first power, third, fifth, etc., then the graph will cross the x-axis at that 0, x equals c. So even multiplicity, odd multiplicity, the graph's going to either bounce off the axis. Some textbooks even say it kisses the x-axis, it just comes right down, touches it and bounces right back off, or it's going to cross right through. Directions here say to sketch the graph of the function below. So let's see if everything we've learned so far in this lesson, if we can kind of start to put together the shape of this graph. So, first of all, what's its degree? This is x to the third, this is x to the second, so in total it would be x to the fifth, so it would have a degree of 5. And this is, first term is going to be positive, and this is going to be positive, so we're looking at a positive fifth power. Okay, so what does that tell us? If it's a positive fifth power, I'm just going to put this in real lightly, it tells me that it comes down on the left and it goes up on the right. Okay, so that's that leading coefficient test put into practice. Now what about zeros? I have zeros at x equals -1 and at x equals 2. Those are coming from these numbers right here. And this one that's at -1 shows odd multiplicity. This one at -2 shows even multiplicity. Okay, but let's go ahead and put those on the graph because we can go ahead and do that. So at -1 we've got a 0. At +2 we have a 0. And so what do we know about these? This one here, it crosses the x-axis, and this, because it's even, it bounces off the x-axis. Okay, so I know it's going to come down here, it's going to go up here, it's going to hit these points. What I don't know anything about are the extrema, and we're not going to go into depth with that, to be quite honest with you, because to actually find the extrema with pre-calculus is rather difficult. We kind of need some calculus techniques to do that, or we need the calculator, the tools on the graphing calculator can do that. So I'm going to draw this kind of just a rough sketch without any regard to how high or low the graph might go. So I'm not going to look at extrema or even consider that at all. So I'm just kind of maybe making some of that up, okay, if that's all right. So just real rough with what we've learned so far, it's coming up through this axis at some point, and again, I don't know how high it's going to go, but at some point it's going to turn back around, it's going to come down, it's going to hit this one, bounce off, and it's going to go up. So I've got my end behavior taken care of, I've got my zeros, I've got the multiplicity dealt with here. The only thing again that we're lacking in discussing is the extrema. And I didn't discuss it, although we could have. I could have discussed the y-intercept, but I didn't do that here. I just wanted to focus on the things that we have talked about so far and using that to help us paint the picture. Okay, last but not least, I want to look at a problem. It's a type of problem we've seen before. Can we write a function from its zeros? Well, we know that any function, any polynomial function, in this case a cubic function, if we know the zeros, we can write the function in a factored form. a 0 of negative 2 represented by the factor x plus 2, the positive 3 represented by x minus 3, and the negative 5 represented by x plus 5. That technically is a cubic function. That's what I want. Now, usually I'm after having you write it in standard form. Standard form would be to multiply this together. So the first two FOIL together are x squared, minus x minus 6, and then times x plus 5. And then we'd multiply these together. And I'm going to skip some steps, but you fill in the work and see if you get this right. It's going to be x to the third. Then I'm looking at plus 4x squared. Then I'm looking at minus 11x, and finally minus 30. And so trying to get to this point right here. I did all the multiplications. I just did them in combined like terms in my head without writing them down. But this is what I'm after, is so multiplying everything together to get to this cubic function.